Why do we even talk about transformation? So this is section 2.5. What is it? I don't want to waste my time. So if it's useful, I would like to learn it. If it's not useful, then why bother? So here is the answer. Transformations will help us visualize graphs of functions very easily. But before we visualize, before we even learn transformations, we have to look at the list of simple functions. I call them basic functions. Simple functions. There are different categories, many different categories of functions. And we're going to list the very, very simple ones. And then we'll talk about transformations. So, list of basic functions. Many of these functions you've seen before, maybe some of them you haven't. So, can anyone give us the simplest possible linear function that you can think of? The simplest possible linear function that you can come up with. F of x equals? What do you think?
Y plus 1.
I hear the music from here.
Y plus 1?
Just x.
X.
Just
plus
x.
1.
Just x.
Just
X. F of x equals x is the simplest possible linear function. And we have to remember its graph. Here's the graph of y equals x, or f of x equals x. Now, we know that functions can be symmetric, odd or even. If you look at this function, what will you say? What type of function is it? Is it odd or even? Yes, indeed, it's odd because it's symmetric with respect to the origin. Well done. Quadratic. Can anyone give us the simplest possible quadratic function? Yes, please.
I have a question.
Yes, please.
So this odd moves through the origin?
Not through the origin. Symmetric with respect to the origin. It can be, for example, it's a very good question. So let me just not put it on the list just yet. So for example, this function is symmetric with respect to the origin, but it does not go through the origin. Its graph is symmetric with respect to the origin. So please do not assume that if the graph does not pass through the origin, it could not be odd. Is that clear? Excellent. Good. Can anyone now give us the simplest possible quadratic function?
X.
Of course. So we know how to graph this. We will get back to it later again. So let's graph it here. We graphed this when we talked about symmetry. So this is y equals x squared. And what would you say? Is this function odd, even, or not symmetric?
Even.
Very good. Perfect. Okay. Absolute value. Can anyone give us the simplest possible absolute value function? The simplest possible absolute value. Of course. That's the simplest possible absolute value function. You may remember this. I hope you do. It's called also, quote unquote, a V function. So this is the graph of the absolute value of x. And can anyone tell us whether this is odd, even, or none of the above?
Even.
Very good. Awesome. It is even. Perfect. Let's look next at, I'm sorry? Is this okay? Are you looking at the absolute value?
Yeah. No, the quadratic.
Oh,
It's okay.
is that okay?
Yeah.
So let's move on to square root. Can anyone give us the simplest possible square root function?
The square root of x.
Of course, the square root of x. Very important graph. What is its domain? Can anyone identify the domain of this function?
0 to infinity.
Very good, indeed. Domain is 0 to infinity. Awesome. And the range also. So this is the graph of y equals the square root of x. Is this odd, even, or none of the above? Very good. Not symmetric. This function is not symmetric. Let's also look at the cube root. What would be the simplest possible cube root? F of x equals the cube root, not x cubed, the cube root of x. Very good. We're going to look at x cubed. It's a very good point. What is the domain of the cube root? Correct. Very good. This function has no restrictions. It's a very nice function. Kind of similar to x squared in a way, but it's really not. So this is y equals the cube root of x. We have to remember these graphs moving forward, because if we don't remember these graphs, there is no point in talking about transformations. So can anyone tell us whether this function is odd, even, or none of the above? Symmetric with respect to the origin. What is in the first quadrant has a copy in the third. That's okay. Very good. So let's say cubic function. Can anyone give us the simplest possible cubic function? And then one more, and then we'll talk about transformations. Very good. Awesome. We know this function. We used it when we talked about symmetry. Here is the graph. Notice one thing here. This is very important. At the origin, the function does not cross like this. See the difference between these two? This is a very slow cross. We will learn in chapter 3 what it means and how it is. How come that these two are totally different? Okay, is this function odd, even, or none of the above? Very good, awesome. And one more. With the last one, I'm not going to do a lot of transformations, but I would like us to see it moving forward because I need it for chapter 4. Rational. Can anyone give us the simplest possible rational function that we can think of? Perfect, of course, 1 over x. So f of x equals 1 over x is the simplest possible rational function. We can find a simpler one. And here is its graph. It's a graph that I used to answer Mason's question. So this is y equals 1 over x. So let's see how long is the list. Linear quadratic, absolute value, 3, 4, 5, 6, 7. So I hope it's not a big deal. We can graph these with the graphing calculator for now if you'd like. I don't think it's a big deal in remembering those. The linear, the quadratic, the square root, the absolute value, we should know. The cubic function we used before. This could be probably new to you. Okay. So now let's summarize the transformations, and we'll talk about them in detail. So transformations now. What are the transformations? Are changes in the functions that we just looked at. So there are 3 different types. The first type, shifts. Second type, reflections. And the last one is stretching or shrinking. Bless you. So shifts, reflections, and stretching and shrinking. Each of them has two different types: horizontal, vertical. Last one, horizontal, vertical. And the middle one with respect to the y-axis and with respect to the x-axis. WRT with respect to the x-axis and the y-axis. So we're going to look at 6 different situations. 1, 2, 3, 4, 5, 6. Okay. So let's start with the simplest possible one, which is shifts. I'm going to create 2 functions. F of x equals the absolute value of x plus 1. And I'm going to create g of x, which is the absolute value of x minus 3. We're asked to graph these functions using transformations. Okay. What is the base function or the basic function that I used from the list of 7? Of course. So the base function is the absolute value of x. Every time I'm asked to use transformations or think of transformations to graph a function, I will always compare the base function to what I'm given. Because, bless you, because there are 2 types of transformations. One that happens horizontally, which means which variable changes. Of course, x, there is nothing else that changes horizontally. And the other type is when a change occurs vertically, so which variable changes if we are talking about vertical. That's it. So now I compare these 2 to see what type of transformation is it. Is it a transformation in x or is it a transformation in y? And here's how I discover that. I look at the absolute value of x, and I see the absolute value of x plus 1. Here I had x inside the absolute value, but here I have x plus 1 inside the absolute value. So what do you think I changed? Did I change y or I changed x? Of course. I changed x into x plus 1. So this must be a transformation that happens on the x-axis, or if you want, horizontally. Okay. So then, when I graph the absolute value of x, I know the graph. Yes, any questions? Any questions? Okay. So this is the absolute value of x. Where do you think this graph will go? Don't answer just yet. Think for a moment. As you see the origin or the x-intercept is at 0. Now x plus 1, where on the x-axis will that x plus 1 have the x-intercept? At 1 or at -1? This is very important to understand. Correct. So this is a left shift of 1. So when I graph this function, I shift it to the left 1. And it's all parallel, perfectly the same, but this is x plus 1. So this is a left shift of 1 unit. Or you can say 1 unit to the left. Let's take a look at x minus 3 now in absolute value. What type of transformation is this, first of all? I'm changing x into x minus 3, which means it's a horizontal shift. Now, where does it go? Does it go to the left or does it go to the right? Exactly. How many units? Yes. So this is the graph of the absolute value of x minus 3. Yes?
I don't understand why. Why do you move to the left instead of the right?
Okay? So if I want to determine the x-intercept for this, what do I do?
For just x?
So I have the function y equals the absolute value of x. How do I find the x-intercept of any function? I set
0.
which one? The x or the y?
X.
That's
Or
the y-intercept.
Y.
Correct. So I have the absolute value of x equals 0, and I get that x equals 0. Agreed?
Correct.
Good. So now for this function, I want to find the same thing. I want to find its x-intercept. What do I have to write? That's okay.
I
I'd rather...
just got it.
Is that okay? So this is x plus 1 equals 0, which means x plus 1 equals 0 or x
So
equals
is
negative 1. So whenever we see a transformation that adds to x, it's this way. Whenever we see a shift, a horizontal shift that subtracts to y, yes, from x, it's this way.
So negative goes right.
I don't want you to memorize that. It's among millions of things that you need to memorize. There is no need. Look for the x-intercept, and then you'll know what happens. That's better, because by tomorrow that will go away. Any questions on horizontal shifts? This is a horizontal shift or horizontal shifts. Okay. So coming back to our list, this is clear, I hope. You can check that. Let's move on. Let's suppose I have a function f of x, which is the square root of x plus 4. And I have another function that is g of x, which is the square root of x minus 2. Like before, we have to identify the base function. Please give me the base function that we used here, or I used here. From the list of 7 functions, I used one in particular. Of course, the square root of x. The next step is I have to establish if there is a change in x or if there is a change in y. So let's look. I have the square root of x, and I have the square root of x. I have the square root of x, and I have the square root of x. So this cannot be a change in x. Okay, because under the square root, the base function is the same. So if it's not a change in x, what can it be? A change in y. And now let's see how. So the graph of the square root of x, we know how it looks like. So this is the graph. Remember, we graphed it a few minutes ago. This is not a straight line. Please do not graph it as a straight line. I'm not saying that you did, but I'm just emphasizing. Good. So what do you think, where will f of x, or what will f of x do to this function? Up how many? Excellent. So 1, 2, 3, 4, and this is the new graph. And this is the square root of x plus 4. Now, can anyone tell us what g will do to the base function? Move it down. The base function will be moved down 2. So this is square root of x minus 2. So then, what do we call this transformation? We call it what? Very good. This is a vertical shift, and we are done with the second one. I would like us to look at the combo for a second. Let's say I have f of x equals x minus 1 squared plus 2. Transformations have to be presented in the order of operations. Note, present all transformations in the order of operations. Similar to, let's say, as if you're deciding, or you need to evaluate this function. If you need to evaluate this function, yes?
Okay, so that sentence is saying go in order as you see.
No.
What is that?
I was just saying. Just 1 second, and I'll ask you if that's clear. So if I am asked to evaluate this function for 10, I will have to perform 10 minus 1 first, square, and then add 2. So in the same way, I would use the transformations in the same order, as if I evaluate it. So first of all, let's identify the base function used here. What was the base function that I used to create f of x?
On your right.
Very good. So the base function is x squared. What is the first transformation on x squared in the order of operations? Say it again.
Can you repeat that question?
Yes. What will be the first transformation that we apply to x squared in order of operations? Very good. X minus 1, which is a what type of shift?
Horizontal.
To the?
Right.
To the right. Very good. Right 1. Excellent. The next step, which is x minus 1 squared plus 2, is the transformation on function 1. So the base function is gone. Now I have to compare these two. And comparing these two, I identify what changes. Comparing this to this and then plus 2 tells me that there is a change in x or a change in y. Yes. So if it's a change in y, this graph will go where? Up to. Very good. This is what we mean by presenting the transformations in order of operations. So when I graph, I will start with graphing the base function always. Here's the base function. Then you told me to shift it right 1. I'm going to shift it right 1. Here it is now. So this is x minus 1 squared. And then you said, perfectly, move it up 2. That's exactly what I'm going to do. I am going to shift this graph, the purple graph, up 2. Here it is. So this is x minus 1 squared plus 2. So I graphed the base function. I shifted it as you told me perfectly. 1 to the right and 2 up. Up. Now, if I say to you, or I give you the following function. Let's say f of x equals x plus 4 squared minus 3. Without doing anything, can you visualize this graph? And the answer is of course, right? The base function is x squared. Where do I shift the graph? Left 4. And where do I go now?
Yeah.
I have to graph. We haven't even graphed it. We didn't use a graphing calculator. We didn't even use paper. We just imagined the graph. Why? Because we knew how the base function looks like, and we're able to apply transformations on it. So now when you put this graph in the graphing calculator, you're not going to say, I didn't expect it. Because you knew what it meant, right? It's x squared, left to your left 4, down 3. What will be the vertex of this graph? Or the minimum of this graph? Negative 4, comma, because we went 4 to the left and 3 down. That's it. And we haven't even graphed the function. We only imagined the graph. Why was this possible? Why was this possible? Because we understood transformations and we knew the base function. Yes, ladies, Lonnie, yes. Michaela.
So I don't understand what the function is saying.
But I want you to, let me tell you why. For 2 reasons. 1, you help me. 2, you help other students who may be shy to ask. And if I don't know what the questions are, then I will not be able to address them. And you help me. So please do. Any questions on this function? Okay, so let's move on to the next set of transformations. Let's say I have now f of x equals negative the square root of x, and g of x is the square root of negative x. We'll figure out what this means, but please give me the base function. From the list of 7 functions, I used one. Exactly. Very good. The square root of x. Awesome. The next step is, remember, we have to identify the type of transformation. Is it on x or is it on y? It cannot be on both at the same time. So it's either x or y. So let's compare, please. I see the square root of x, and I see the square root of x. Can this be a transformation on x? No. Excellent. I see plus here, but I see minus here. So what changes if x does not change? There is nothing that touches x. It's the same square root of x and the square root of x. So then it must be a transformation. If it's not on x, it must be on. Good. Perfect. So if this is a positive number, this will always be a negative number. What does that mean? From positive to negative. Transformation on y, as you said. From positive to negative. Reflect with respect to the x-axis. This is a reflection. With respect to WRT, with respect to the x-axis. Let's graph these two, and then we'll come back to the third one in a second. So here is our square root of x. Here's the graph. And you told me that f of x, which is negative of all these values, is a reflection with respect to the x-axis. I completely agree. So the original graph is in orange, and the reflection is in blue. Okay, now let's talk about the other one. Let's compare first. So I have inside the square root, I have x, and here I have negative x. Is it a transformation on x or a transformation on y? Of course it's on x. The transformation touches x. It has to be on x. But what does that mean? From positive x to negative x, or from negative x to positive x. What transformation is this? Reflection with respect to? Yes, very good. So this one is reflection with respect to the y-axis. Very good. So then the graph, the original graph, the base function, will reflect with respect to the y-axis. Questions so far, please? I want to stop and look at the combo. So you can check these two as well. Oh, no. Any questions? Yes, please.
When you're done with this one, can you go back to the green one?
Say that again.
The x plus 4 squared.
Yes. Any questions?
Yeah, how did you get b?
That's the vertex. That's the vertex.
So you're just taking it and doing the opposite?
Okay.
Yeah.
So we said this was x squared. This is x plus 4 squared. And this is x plus 4 squared minus 3. So therefore, the vertex is a negative 4 comma negative 3. Is that better?
Yeah.
Perfect.
The vertex is basically how it's based on.
No, the vertex is the only point that represents the max or min of a quadratic function. It's called vertex. No other function has a vertex. Okay? So this point is the vertex of a quadratic function. That's the name of it. Okay, other questions? Other questions? Okay, perfect. So let's look at the following combo. So f of x equals negative x plus 1 squared minus 4. We want to picture this quickly before we even list the transformations. Which base function will I have to deal with here? Here it is. Where do I shift it first? Careful. In order of operations.
Down.
Left, no. Left one, then no, in order of operations.
Flip it.
Flip it, and then down 4. One more time. X squared, 1 to your left, Flip, down 4. Can anyone give us the vertex now? Very good. -1, -4. Very good.
Why do you flip that?
Because it's minus here. In order of operations. In order of operations. So, can anyone give us the base function? Ladies, please ask.
I'm just trying to see, are you gonna draw it?
Of course.
Okay.
Of course. I did that so to show how important transformations are. I don't really need to graph anything. We already have an image of the graph in our heads.
Okay, so you said it's left one down. Yeah.
Okay, so the base function here is?
X squared.
Very good. The first transformation on x squared. So x plus 1 squared, left 1. The next transformation on number 1, please.
It's like -1.
Very good. Negative x plus 1 squared. This is a transformation on number 1. What kind? Reflect. Very good. Reflect with respect to the x-axis. Awesome. Great job. And finally, I have this. Very good. Down 4 of this previous graph. Very good. So x squared is the original graph. Base function. You told me to flip it. I'm sorry, you told me to move it to the left 1. So this is x plus 1 squared. Then you perfectly told me to reflect it, and I did. So this is negative x plus 1 squared. And then you said, now you have to move it down 4. And I did. I will. Right here. So here's the graph. So this is the graph of negative x plus 1 squared minus 4. So that's the purpose, one of the purposes, I should say. It's not the only reason why we study transformations, to picture graphs in our heads quickly. But also, let's say tomorrow or soon or next year you become data analysts and you collect data and you plot the data, and let's say you get something like this. Which kind of function would you think of from the 7 functions that we looked at? The square root. You already know there must be a transformation of the square root. It may be a stretching or shrinking. We haven't discussed that yet, but it's definitely an upshift of some radical function, square root function, of course. Okay, the last 2 transformations. So let's take a look. I'm going to come up with 2 functions. Let's say f of x equals, I'm thinking, to the absolute value of x. And g of x equals 1/2 the absolute value of x. Like before, we have to identify the base function. Which function did I use in this case? Very good, of course, thank you very much. And now let's think, first of all, what changes? This is very important, so that I know if it's a transformation on x or on y. It cannot be on both. So let's analyze. I see the absolute value of x, and I see the absolute value of x untouched. There is something outside. Same thing here, the absolute value of x and the absolute value of x completely untouched. Just something outside. Okay, so what do you think then? Is it a transformation that is on the x-axis or on the y-axis? Absolutely on the y-axis. Great job. So let's graph this. The absolute value of x first. Right in the middle of both quadrants. And now, please tell me, what do you think will happen if all these values, all of these, which is this value or this value, will be multiplied by 2? What will happen? Exactly, it's a vertical stretching by a factor of 2. This piece doubled. this piece doubled, and so on and so forth. So this is indeed twice the absolute value of x. It has all heights, twice as much for every x value. And this is a vertical stretching by a factor of 2. Excellent. Now please tell me, what do you think will happen if we multiply all y values by 1/2? So they will be divided, correct? All the y values will be divided by 2, correct? Yes, everyone? So then this height will be halved, this one will be halved, and so on and so forth. So this is the new graph. But because it's multiplication, otherwise it would have been a symbol in there. If there is no symbol, it must be product. Very good. So this is 1/2 the absolute value of x. So what will the red graph represent? It's still a vertical, but it's not a stretching, but a, yes, a shrinking. Vertical, shrinking. Any questions? Any questions? Okay, so we looked at this one, stretching and shrinking, which is vertical for both vertical. So now we talk about the last one. Let me show you a combo first, and then we look at the last one, and then we can move on. Here it is. F of x equals -2 x plus 1 squared plus 4. Okay, which base function did I use now? Perfect. Where do I go? I go left one again. Then I have to separate the -2, the negatives from 2. So first I multiply by 2. What do I do when I multiply by 2? Yes? And then reflect, and then up 4. Can you picture the graph? Yeah, x squared, 1 to the left, stretched, reflected, up 4. What is the vertex in this case? That's it. Very good. Awesome. Well done. Okay, so let's graph it. Let's list the transformations in order of operations. You're doing well. I'm happy. So number 1, you already told me that the base was x squared. So the first transformation on x squared is? Very good. Awesome. Great job. So which is left 1. Good. The second transformation, is on this, which is twice x plus 1 squared. Vertical stretching by a factor of 2. Perfect. Number 3 will be -2 parentheses x plus 1 squared. Yes. Reflect with respect to? Yes, with respect to the x-axis. Awesome. And number 4 is the final function, which is a transformation on number 3. It's not a transformation on 2 or 1 or the base. Number 4 is a transformation on number 3. So you see, these do not change. It's just up 4. That's my purpose, to help you visualize the graph before you even touch the graphing calculator or attempt to graph it. That's the purpose of this. Understanding these functions, so when you look at the graph in the graphing calculator, you're not going to say, oh, I don't understand where it's coming from. Ready? So let's graph all of them. And then let's look at the last one. So we had x squared. Then you told me to move it left 1. Here's left 1. Then you told me to stretch it vertically. You understand that these graphs are no perfect graphs. They can be perfect graphs. We're just using transformations to see the shape quickly. Okay, it's not, we haven't plotted points here. Okay, so this is the negative, no, it's not yet negative. So it's 2x plus 1 squared. These are not perfect graphs, and they're not supposed to be perfect graphs. So I'm going to reflect the green graph. So this is negative 2x plus 1 squared. And then you told me to shift this one where? Perfect. Up 4. 1, 2, 3, 4. Somewhere here, I get the graph. This is final. I'm going to just shade it so it's clear when you look at the graph. Okay, feeling a little bit better. Yes, please. Taylor?
So like on a test, are you gonna have to grab each step?
Yes. Yes. Now, if you present the steps, writing each and every step, this represents this, 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 I'm fine if you just graph the final. But I think it's wise to present all of them. But, okay, so let's take a look at the following. Let's suppose I have f of x, which is x cubed. I want to caution you, the very last transformation is not what you would expect. Okay, it's the opposite of what you would expect. So be careful with this one. I normally present this transformation in pre-calculus only because it's very valuable for trig functions. Since here we don't have trig functions, I'm just going to show you a couple of examples. Something from the book. Okay, so f of x equals x cubed. Now I would like you to tell me, how do we get this? We know how to evaluate a function for anything we can think of, including for 2x. So please tell me what to write as the first step. My tent is falling off. First step. Yes, I'm ready. Just tell me what to write. Very good. Awesome. Great job. And then? Excellent. Is everyone in the clear with this? Do we all agree with this? You just evaluate. It's a function of blah, blah cubed. Now this is your blah, and it's blah cubed. You just have to evaluate. It's like you evaluate for 5. You have 5 to the third. If you evaluate for 2x, you will still have 2x to the third. Same thing. Okay? So now how do I simplify this? Great job.
6,
No, 2 to the third is not 6, but 2 to the third is 8. Very good. And then x cubed. Perfect. So forget about this for a moment. Can you please tell me what I changed? Look at this base function and look at this function and tell me what I changed. Did I change x or did I change y? X, excellent. I changed x into twice x or 2x. Very good. And now forget about this. And tell me now, what did I change? From this to this. I did change y, correct? So I have x cubed, and all of a sudden I have 8x cubed. Let's focus on the result for a moment. So this is x cubed, right? What type of transformation is this one? 8x cubed. Is it this, or is it this? This one, right? Because we multiply by a number greater than 1. So this is x cubed, but this is 8x cubed. Would you agree? Right? Now think for a moment. I doubled x. You would have expected this to happen, right? I doubled x. From x equals 1 to 2. From x equals 2 to 4. From x equals 5 to 10. But actually, what happens is the completely opposite. So when we change x into twice x, this is a horizontal shrinking of the graph. Not a horizontal stretching like you would expect. And obviously, the other one, when we change x into 1/2 x, you would think that what would happen is we would divide all x values by 2, but it's quite the opposite. This is a horizontal stretching of the graph. And now I would like to show you with an example what we need to do. And this is on page 295. 295. We are given a graph, and we're asked to graph. They're all combos for now. So let's suppose we want to graph f of 1/2 x. So we have this graph. I'm gonna copy it in a second, and I'm going to ask us and you to find or graph f of twice x, and then f of 1/2 x if you want. Which one would you prefer? Twice x or 1/2 x? Which one? 1/2 x. What do you expect will happen? You would expect for the graph to shrink. It's totally opposite. The graph will stretch by a factor of 2 if we'd like to graph f of 1/2. Ready? So let's graph this. It's very easy to copy it. Ready? So this is problem 46 on page 295. It's not 46, I just made it up. So let's make it, we can choose one from there, but let's say I'm copying from the graph from 295. Okay, so here's our graph. -4, -2, and then -2, 0, and then 0, 2, and then 2, 2, and then 4, 0. That's it. This is the graph of f of x. We're asked, or you picked f of 1/2 x. So we want to graph this function. So this point is at x equals -4. Where will it go? Remember, this is all horizontal. This point will go where? 1, 2, 3, 4. It will go here. All x values get multiplied by 2, not divided by 2. It's the opposite. This point is at x equals -2. Where will it go? Very good, awesome, right here. This point has x equals 0. Where will it go? It has x equals 0. We multiply 0 by 2. Where will it go? It will stay. Very good. This point has x2. Where will it go? Very good. And this point is at x equals 4. Where will it go? So here is, just to make sure it's clear, I'm going to do this. This is the graph of f 1/2 x. What if now we want to graph f of twice x? This x value is at -4. Where will it go? -4 divided by 2 is -2. This point is at -2. Where will it go now? Very good, awesome. This point is at 0. Where will it go now? Very good. This point is at 2. Where will it go now? At 1. Very good. This point is at 4. Where will it go now? At 2. So this is the graph. This graph is f of twice x. So when we replace x by twice x, we shrink the graph horizontally. When we replace it by 1/2 x, we stretch the graph horizontally. Yes? Okay? It's always the opposite. So if you have 1/2 x, you're multiplying all x values by 2. It's horizontal. Only horizontal. Nothing vertical changes. This is a horizontal change or transformation. So if you have f of 1/2 x, you will multiply all x values by 2. And there is no change in y. No point changes its y value. Because remember, there is no transformation that performs two changes in x and y at the same time. So if the x value is at -4, you multiply -4 by 2, and you horizontally shift or move the graph to -8.
Right.
If x is at -2, you multiply -2 by 2, and this point moves here. If x equals 0, you multiply that by 2, and it stays because 0 times 2 is 0. This is x equals 2. You multiply 2 by 2 to get it at 4. And this final x is at 4. You multiply by 2, and you get it at 8. Oh, of course, anything can be. It can be 1/5 x. Then you will multiply all the x values by 5. Of course, it depends on this number. If this one is 5, you cannot multiply x values by 2, right? You have to multiply by 5.
Okay, can you explain the shrinking again?
Yes, yes. So here we have to determine the graph or find the graph f of twice x. So this is at -4. And -4 divided by 2 will go to -2. This point is at -2. -2 divided by 2 will land at -1. 0 divided by 2 is at 0. 2 divided by 2 moves to 1. And 4 divided by 2 moves to 2. So that's how we get the red graph. So it's exactly the opposite. This is the only one that is the opposite of what you would expect normally.